Hey guys, this is Arv here, and I'm gonna brief you on two AP Physics 1 problems on spring force. This is the first quiz we got from school, quiz homework, and these are the answers to those problems and how to solve those problems. The first question on the quiz. Two students want to know the spring constant of a small spring. When a 95.4 gram mass is hung vertically from the spring, the change in length is 0.29 centimeters. So that's the x change, the delta x. Assuming the spring follows Hooke's law, what is the spring constant of the spring? Round to the nearest 0.01 newtons per meter. Okay, so let's begin with the question. So we have the mass, so everything is given. Okay, so begin. So what we have is the mass, that's 95.4 grams. We need to convert it to the standard units, 0.0954 kg. The delta x is 0.29 centimeters, which is basically 0.0029 meters. Okay, so let's draw the free body diagram to understand what's exactly happening here. So the spring is attached to a mass and is hung vertically. So basically, there is no acceleration up or down. So there is a force of gravity always, and that's equal to mg. And there's a force of the spring. But since there's no acceleration up or down, the force of the spring equals the force of gravity. All right. So this is the free body diagram. Now these are the important formulas to remember, that the force of the spring is equal to the k constant times the delta x. That's the change in length. And then Fg is also equal to mg, where g is the 9.8 meters per second squared acceleration of the force of gravity. So the sum of forces formula. So what we begin with is Fs, that's force of spring minus force of gravity, is equal to mass times acceleration. Like I told you, so force of spring minus force of gravity is equal to the mass we have, and the acceleration is 0 because they're not moving up or down. It's constant, which basically gives us Fs minus Fg is equal to 0, which states that Fs is equal to Fg if I move Fg from here to here. So now going back to the formula, Fs is basically equal to Kx. Here, the absolute value of x and multiplied to k. So it's basically Kx is equal to mg. Mg is basically Fg here. And so Kx value, Kx is equal to 0.0954 kg, that's the mass, times gravity, which is 9.8 meters per second squared. So now we need to find the k value. That's the main idea of this question. And we have the x value, which is 0.0029 meters. So we can figure that out. So k multiplied to 0.0029 meters is equal to 0.0954 kgs times 9.8. We can find k by multiplying the mass times g divided by the x value, which is basically this equation. And using after solving the equation, we get 322.3 newtons per meters. That's the k value. The symbols for k is newtons per meter, and this is the answer. All right, so that's the first question, and we found an answer to that. Now going on to the third question. The second question is a word problem, is a multiple choice problem, and so it should be pretty easy for you guys. This is the third problem. So the third problem states that a spring has a constant which is constant k of 73.3 newtons per meter, and is compressed to 2.64 centimeters, so which is basically equal to 0.0264 meters. We converted that thing to meters. Okay, what is the magnitude of this force that is required to compress the string round to the nearest 0.01 newtons? Okay, so they're basically asking us to find the force. Okay, so this is a pretty easy sum. Okay, so you begin with what's given to us. What's given to us is the k value, 73.3 newtons per meter, and we have the delta x, which is 2.64 centimeters, which transfers to 0.0264 meters. We have to find the force. So what is the formula? The formula is basically this. Force of spring is equal to constant times the delta x, which is the change in length. So we have the so we can do that. So force Fs is equal to K, the K value is given to us 73.3 newtons per meter, multiplied to 0.0264 meters. The meters and meters cancel out, and when you multiply these two values, you get a force of 1.94 newtons. And this is the answer to the question. This is a pretty easy one. I just thought of solving it in front of you, so just make sure if your answers are right. So these two are the answers, and that's all for the day. Enjoy the rest of the day, and I'll keep posting more videos. Please like and subscribe. Thank you.